Divide by place value. Track the remainder. Multiply to check.
In the gridded garden, Pip the fox and Kit the wise math Sheba face a harvest too large to share one seed at a time. Counting out thousands of units individually is slow and prone to error. To handle a harvest of this scale, we need a more efficient system. Kit's method relies on 4 repeatable steps. Split the big number by its place value, share each piece into equal rows, add those pieces back together, and multiply to check the work. Division allows us to manage these massive counts by shifting whole organized groups of hundreds, tens, and ones at a time. We'll start with a harvest of 936 seeds, which Pip needs to share into 3 equal rows. First, he breaks the dividend into its place value components, 900, 30, and 6. He rakes the 900 bundle across the 3 rows, placing 300 seeds in each row. Next, the 30 bundle splits into 3 rows of 10, and the final 6 seeds distribute into 3 rows of 2. Combining these pieces, 300, 10, and 2, reveals a quotient of 312. Multiplying 312 by the 3 rows rebuilds the original 936. When a number breaks cleanly along place value lines, multiplication confirms the accuracy of the division immediately. Most harvests are not so tidy. Pip now has 785 seeds to share into 6 equal rows. Using an area model, 6 rows form one side of a garden plot. We start with the largest chunk, 6 rows of 100 seeds. Subtracting 600 leaves 185. Pip adds 6 rows of 30, using 180, leaving exactly 5 seeds. At this point, we have 6 rows to fill, but only 5 seeds are left in the pile. Because we cannot make another full set of 6, these 5 seeds are designated as the remainder. Division stops when the remaining units are fewer than the number of rows. We add the row pieces, 130, for a final answer of 130, remainder 5. To check this, we multiply the 6 rows by 130 to get 780. Adding the 5 leftover seeds brings us back to our original 785. The remainder represents the portion that cannot be shared equally, ensuring the mathematical logic holds even when the harvest is uneven. We can now apply this same logic to process much larger 4-digit harvests. Pip faces his final challenge, sharing 3,636 seeds into 3 equal rows. He splits the dividend into 3,000, 600, 30, and 6. Raking these into 3 rows puts 1,000, 200, 10, and 2 seeds in each. Combining them gives a final quotient of 1,212. This demonstrates that thousands are managed with the same place value principles we use for small numbers. This process works because division is the structural inverse of multiplication. When Pip pushes these 3 rows of 1,212 back together, they rebuild the original total of 3,636. The sequence remains the same at any scale: split by place value, share the pieces, identify the remainder, and multiply to check. Before you leave the garden, consider how you would apply this to a harvest of 868 seeds shared into 4 rows. This method provides a consistent logic for deconstructing and reconstructing numbers of any size. I'll see you in the next field.
Share by place value. Remainders stay honest. Quotients rebuild totals.